Alright, in this item we've got a air conditioning compressor unit that is supported by the beam AC, and then that is supported in turn by two rods up to the roof. And we're asked to find here the axial force in each of the rods. Right, so there's pin connections at each end, and so the free-body diagram of AC, the beam AC, is going to be the following. We've got the compressor weight of 2,000 pounds, that's a kip per thousand, and then we've got the hanger force here at C, and we got the hanger force at A. Now you might say, well, it's a pin, so why don't I show then the horizontal component for each one of those? Well, if they exist, they'll be equal and opposite, and they won't be the axial force in the rod. But note also, these are pin connected members. That means if they have to be two force members, there's no other applied force on them. So there is only these two unknowns to show. It does mean that in reality this thing could swing back and forth, and if we were to actually make something like this, there would be a little bit of instability here. That doesn't affect then this sort of overall equilibrium position for the system and our ability to go calculate what we've been asked to find, which we'll do with the equilibrium equations. And we can take some moments about point A. Let's see here. We've got a 3-foot moment arm over the 2-kip load. We've got a 5-foot total distance from C to A, and so that means let's take counterclockwise is positive, so we'll have minus 2 kips times 3 feet, because that tends to want to spin in a counterclockwise way about point A. And then the other one will be 5 feet moment arm times our FC that we don't know, set that equal to 0 because that's equilibrium, and F sub C then will equal 3/5 of the 2 kips, or 1.2 kips. Of course, that will turn out to be in tension. It's pulling away from the free body. We'll do the same thing independently about point C, rather than using some forces. I'm going to take clockwise positive this time, and we'll have 5 feet times our unknown FA minus 2 kips times 2 feet, and set that equal to 0. And notice now FA will be equal to 2/5 of the 2 kips, right? Feet over feet, just like here we have feet over feet. And so that's just going to be equal then to 0.8 kips, also tension. Note that we can now check equilibrium by some forces in the y, and we're going to have 2 kips going up minus, oops, that's not either true. We have, 0.8 kips acting up at A, minus 2 kips acting down here at 3 foot over, and then we got the plus 1.2 kips. That is going to be equal to 0 the way it should. So those are the correct values then for our requested items.